Hi, my name is Dr. Gerthen Bosman, and I'm an academic staff member at the Physics Department at Stellenbosch University. In this talk, I will present vital information of how our undergraduate and postgraduate programs, as well as typical career paths stemming from studying physics at SU. Hopefully, this will convince you that physics is indeed the right discipline for you. The layout of this presentation is as follows. I will start with providing key reasons why studying physics is so interesting, fulfilling, and essential for technological advancement. Second, I will elaborate on what to expect during our undergraduate physics program. Thirdly, I will briefly summarize our postgraduate physics programs. Lastly, we will look at what career opportunities physics affords you. Now, it is widely understood that physics is one of the most fundamental scientific disciplines. The reason for this is that the physical laws which physicists study find application in many other fields of study, such as astronomy, biology, chemistry, engineering, environmental science, geology, medicine, material science, and photonics, just to name a few. This is not surprising, as the primary goal of physics is to understand how nature and technology works from first principles. In our physics courses, the mathematical beauty of the universe at various time and length scales will be revealed, and studying physics will strengthen your quantitative reasoning and problem-solving skills even in areas beyond physics. Now, it is crucial to note that in a world rapidly accelerating towards the use of generative artificial intelligence, with these new tools can write completed code, derive equations, simulate physical systems, and even draft research outputs, it is important to note that studying physics, or physics in general, is not about calculating answers, but rather about understanding reality itself. Our 3-year undergraduate physics program currently offers 3 specific focal areas at the undergraduate level. The focal areas were designed in such a way that they best prepare students for specialization in the indicated areas and for a BSc honors in physics, as well as for the research interests and activities of the Nuclear Physics Group, Stellenbosch Photonics Institute, and the National Institute for Theoretical and Computational Sciences in the Physics Department. In the first and second years, these focal areas offer the same physics modules. However, in the third year, you can choose between a dedicated experimental physics module and a computational physics module. Note that apart from majoring in physics, if you choose and complete the appropriate elective modules from chemistry, biochemistry, mathematics, and computer science, this can also lead to a double major with any of the aforementioned disciplines and physics. As an example, let us consider the first focal area. In this particular focal area, the appropriate elective modules may also lead to an honors program in chemistry and computer science. Additionally, you will notice that in this focal area, you have the freedom to select applied mathematics and probability theory and statistics, which offer a well-rounded background for the following years. For this focal area, in year 2, you again have the opportunity to choose second-year elective modules. However, there's a small caveat. Note that the majority of the second-year modules have passed prerequisites. Take Chemistry 214 as an example. To continue with this module, a pass is required in Chemistry 124 or 164 as well as 144. Therefore, care must be taken when selecting these modules. In fact, my advice would be to first develop a good understanding of what you would like to pair with physics. Have a look at our third-year program and review the elective modules at third-year level and their prerequisite modules. All this information is readily available in our faculty yearbook. In year 3, due to the various permutations of the second-year elective modules, we define 3 options to choose from. These are meant to make selecting easier and to create a path that best complements your strengths and interests. Option 1, with appropriate elective modules, must be taken by individuals wanting to major in physics and chemistry. Now, pairing chemistry with physics allows you to understand matter from both a molecular and fundamental perspective, linking atomic structure, energy and dynamics to real-world materials and reactions. You gain the tools to explore cutting-edge fields such as nanotechnology, renewable energy, spectroscopy, material science, and pharmaceutical development. This combination is ideal for students who are curious about how microscopic interactions give rise to observable properties and who enjoy connecting theory with experimental insight. Option 2 features applied mathematics more prominently. Pairing physics with applied mathematics equips you to have moved beyond memorizing formulas and instead derive, model, and truly understand the laws that govern complex systems. You gain the analytical tools to solve real-world problems rigorously, from quantum technology and climate modeling to AI and advanced materials, while developing rare, high-level problem-solving skills. This combination is ideal for students who enjoy deep thinking, precision, and the satisfaction of uncovering the structure behind how the world works. Finally, option 3 gives you the possibility to double major in physics and computer science. Pairing computer science with physics equips you to model, simulate, and analyze complex physical systems using the power of modern computation. You develop the ability to translate fundamental laws into algorithms, enabling work in areas such as artificial intelligence, data science, computational physics, quantum computing, and advanced instrumentation. This combination is ideal for students who enjoy logical thinking, problem solving, and using code as a tool to explore and understand the physical world. Now, this leads us to the postgraduate program. The postgraduate program in physics starts with a one-year BSc honors program. This level is where specialization into specific physics streams occur. Given the history and active research in physics at Stellenbosch University, the physics department offers the following 4 focal areas: nuclear physics, radiation and health physics, laser physics, and theoretical physics. The details of the admission requirements appear in the Faculty of Science yearbook. However, I would like to draw your attention to one specific admission requirement for this program. It is required that the candidate holds a BSc degree with physics as a major, with an average final mark of at least 60% in Physics 3. This means that even if you completed, for instance, the focal area aligned with a specific postgraduate focal area, which is preferred, your performance in Physics 3 modules is the primary selection criterion. Therefore, you still have the option to pivot to any of the 4 focal areas in your honors year. The one-year honors program consists of a range of specialized advanced physics modules and a research project supervised by a member of the physics academic staff. Now, an MSc degree in physics is typically completed within 2 years. The specific admission requirements include an appropriate BSc honors degree or an equivalent qualification as approved by Senate. The program structure is as follows. Now, after consultation between the MSc candidate and a suitable supervisor, the department formalizes the process by appointing the preferred supervisor to the candidate. The student is expected to conduct independent literature review and research in consultation with the supervisor. Furthermore, advanced seminars and courseworks form part of the approved by the department, forms part of the MSc studies and contribute towards the final mark for the program. Do note that an MSc in physics transforms you from someone who applies known sciences into someone capable of advancing it. while still developing deep analytical, technical, and problem-solving skills that remain valuable in any high-level quantitative field. Technological development the world over feeds off skilled individuals making novel discoveries in the fundamental sciences. Therefore, we encourage our cohort to pursue a doctoral degree. The physics PhD degree is normally completed within 3 years. The typical admission requirements is an appropriate MSc degree or an equivalent qualification as approved by the Senate. As with the MSc program, in the PhD program, a suitable supervisor is appointed to guide the candidate in conducting novel, independent research which will eventually be presented in a dissertation. Now, given the sheer scope of physics graduates have access to a wide range of career opportunities. Here I will highlight 4 career paths. The first is the academic career path. This route is particularly well suited to physics graduates as it requires strong analytical ability, intellectual curiosity, and research aptitude, together with essential professional skills such as leadership, teamwork, communication, management, and scientific writing. An academic career in physics involves lecturing at tertiary level while conducting original research on fundamental aspects of nature and their practical applications. Employment opportunities are typically found at universities, research institutes, national laboratories, and universities of technology. And this path generally requires a PhD in physics. The second career path lies within business, industry, and corporate sectors, where physics graduates leverage their analytical strength, research capability, and leadership skills to drive innovation, manage projects, and optimize complex processes. Opportunities are found in manufacturing industries, strategic management consulting, and financial services where quantitative thinking and problem solving are highly valued. Entry into this pathway technically requires at least an honors degree in physics, with a MSc or PhD offering access to more specialized or senior roles, and additional business qualifications often enhancing your career progression. The third career path is in teaching, where physics graduates are involved in classroom instruction and course development, with employment opportunities in the public and private school sector. This pathway typically requires a BSc, honors, MSc, or a PhD in physics, together with a recognized teaching qualification. The fourth career path lies in research, policy, and management within government, where physics graduates contribute to policy research and development in governmental institutions. This pathway typically requires an honors, master's, or PhD in physics, often complemented by a qualification in policy or public administration, and involves assisting in the drafting and evaluation of policies that guide national decision making and contribute to positive societal outcomes. In a recent poll of Stellenbosch University physics alumni, we found that our graduates pursue a broad spectrum of careers, including data scientists and analysts, software developers, control system engineers, entrepreneurs in the education and environmental physics sectors, instrumentation scientists, astronomers, and laser scientists. We have now reached the end of this presentation. For more information on the topics discussed, please visit the physics department at physics.sun.ac.za. We hope to see you next year.